There was one day I was really afraid to step out my door on my own, and when I did, they all dropped me. It was cold and a test of mine. I finally started to break out of my social anxiety. Do you think they will apologize to me? No, they don't even know. They are simply too busy. So I don't care about them anymore. If they were dead or something, it's none of my business. Do you know how much I cried? Now that's too easy. I still have to put on a smile after all of this. I have such a terrible life, but I must fight for my dreams. My dream is making high ratio Lucy image. There's barely anyone attempt that. I knew I would never be AVIF or JPEG XR, so just let me quit. Nothing beats DCT or Kahneman love transform, and they already exploring that as much as possible with ADST. You can take a look at the specs. In compression, if you resort to transporting the data instead of using another algorithm, that means they are desperate. Help me! Help me! Help me! Help me! Help! I need help! I need help! Help me! Help me! Help me! Help me! I need the internet right now, or else I will die from it. Help! I am terminally online. I'm sure I will die without the internet, cause I can't live without it. I already got excited for this. I'm already cut off for 6 hours, and I can't stand it. 我名是寫定定，而這可寫諾寫計起咗，落可這人之也大數。咪踢走我電話啊！家人是錯，但只是我做虧心事，阿妹佢會被先被驚。三面兩刀，恰好杀气腾腾，端起碗吃肉，放下筷子骂娘。暗がどれも同じ見える。Now I know why no one research on this. Because there's no money to pay you. It sucks. Alright, I have wiped my tear, and now I'm going without a script, so you might not understand what I'm saying. So you might not understand what I'm saying because my English is so bad. Now let's move on. And I saw satellite image compression. I don't know why everyone is so focused on satellite image. And I see hybrid. Yeah, that means multiple transform coding. DWT is, well, DWT is discrete wavelet transform. Oh wait, gonna ignore that. So SVD, well, I need a ChatGPT to explain it. Okay, going to ask ChatGPT, what is SVD? Oh, where can I find? Get discrete wavelet transform, discrete cosine transform, singular value decomposition. Okay, gonna ask again, what is singular value decompose? Oh my god. Now let's try again. I'm gonna ask why you need those. Why do you need those? And they say U, sigma, and V work together to reveal hidden structure in a matrix, providing powerful tool for data analysis, interpretation, whatever. I don't know how it works. But it was say something. Okay, I have the permission to show this article. And I even can edit, I think, because it is Creative Commons by 4. Roughly share. You can even edit it, but you must give credit and no additional restriction. So we're gonna take a look. Oh my god. Storing image, console alone, blah blah blah. Oh, but one interesting for me is wait. One interesting is it got 2.51 mean square error, which is low. If you do it on JPEG, you always get something like 10,000, 100,000, or million. So a single digit number is pretty rare. Mainly it's just routing error causing it. So this is the introduction. I already know all of this, but you just read this aim and objective with the header. They use discrete cosine transform and discrete wavelet and SVD. Right. Okay. This talking about image compression. You can skip it. We don't need to know those. What's this? I don't really understand. Oh. For fingertip bands. Low, 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 high, and high, high. I got one for you. So I have a Haar wavelet. I don't remember. It must be. The low means the smooth detail, and low high means low and high frequency detail. And high low is probably this. I don't remember. I'm just bad at reading those algorithms because I don't understand them. JPEG and HGIF support by DCT. Fewer cosine functions are needed to approximate a typical signal. So the reason why DCT is so effective is that the only thing you need care about is this one corner, top left corner. It's 1047 debunk. When you get something like Haar wavelet, you are managing 4 of them, like these 4 corners, and you can't even delete those 3 corners too much. So that's really tricky to compress. But with DCT, everything is so much easier. Yeah, more quality too. Just look at this. Everything is concentrated in this corner. You just have to get rid of those numbers. Right. That's why DCT is so good. Because they concentrate in the top left corner. Now the singular decomposition. That's not a good algorithm. Right, this It's pretty bad. Consider you are just rounding the number to int 8 and you still using float to restore the image. It's still pretty bad, this algorithm. You can see the artifacts, D62, but in here they are well messed up. So I try with just get rid 3. Right shift is mean route to nearest 3, I can say, and then put it back. I have to tell you about binary number. So I have to show you what it looks like. Now this means get rid the first 2 number, get rid of last 2 number. So it turned into 1 0, which means 2. It was 4 3. It was 7. Now it's 3. Okay, let's push to left again. Let's push 2 0 to left again. So it will become 4. No, that's 7, sorry. This number is 7. 1, 2, 4, 8, 16. So this number is 8. It was 8 and 3. So this number is 11. Then I delete the 2 number with right shift. So it will left with, I think it's 3. No, it's 2. So I add the 2 number back with right shift. So it's 8 now. So this is how the shifting works. Man, you use those simple shifting and you still getting better score than SVD. I'm sick. Do you see? Even a simple shifting can beat this algorithm. I just use is this 63. It's exactly the same as the those one I calculated. It was 128 and 64. 32. The uint number is 25, 255, and then to 127. 6-bit number is 63. Do you understand? I am pushing the number and get rid the 2 number and I add it back. 8-bit number to 16, 6-bit number like this. I hope you can understand because it's really hard to explain this. So this SVD is singular value decomposition. You can ask ChatGPT, but it will give you crappy answer unless you create a custom instruction. Here's the name, here's the description, here's the introductions. So when you put this, it will give you better answer. Let's try. What is Haar wavelet? It will be less confusing than the original one. Now let's try with my custom instruction. They will give you overview sometimes. Then and start with detailed explanation. Okay, yeah, simple tool data compression method. Imagine it like a mathematical Microsoft that turns invisibility future of a signal or image, like edge or sudden change. It's so easy to understand. Think of it like a puzzle taking apart to see each individual piece. Now let's see the default model. Its name it's giving you history lecture. Okay. They just say what it does, but they don't explain what it did. Key characteristic of simplicity. To value. Who the hell cares about what is the number? Okay, now all of I don't know what that means. I need to read English more. This is so hard to understand. It's so confusing to read. The hardware can be easily implemented using binary operation. Look, they don't even tell you. I mean, the model don't even tell you how to imagine it. It's very difficult to understand. Think of it like taking puzzle apart. Think it's like using a ruler, using up and down in a line graph. It's like using a magnifying glass to spot where the image suddenly changes light to dark. Imagine packing for a trip and you only bring the essential. Simplicity effective. It's thorough. I didn't tell them to not mentioning people, but wow, they can't even follow their instruction. Right. Real example in everyday life, how wavelet can be found in JPEG 2000 image compression, removing noise from audio recording, within financial analysis to for sudden changes in stock price. They even give you real world example because I tell them to do it. In summary, I tell them to stop putting, but somehow they don't tell them. They don't tell them to not make a summary, because I tell them make an overview before you explain those. They ignore my instruction. I tell them do not make the summary. What the hell is going on? I think you get it. My custom instruction is better. So we can go back to this now. UAVT. Wow. ChatGPT can even explain better than this paper, so I don't really like paper. Just slap on my custom instruction. What the hell? The internet is like a potato that never cooks. Never fully cooks. SVD is a loosey match compression algorithm. I already tried SVD, it's terrible. Even a bitwise shift can do it better. I don't get it, why they write those. Is this even related to satellite image or the SVD algorithm? That's why I really hate reading papers. They feel like it's someone train of thought rather than teaching. Okay, now they say someone's name and then showing compression grayscale is shown. Oh. Wow, that's low of word, but nothing helpful. Imagine GPT speak like this. Wow, you would be confused. Okay, I look the SVD DCT. Okay, they combine SVD DCT. Show it's better for some reason. Median filter. Long length coding. Wait. It's not long length coding. I feel like that's a typo, but I see RLC. So it's not a typo. Right. Oh, now they throw up those genetic algorithm who knows what is it? And particle song optimization. Now they are getting. That's not funny. They don't even explain why is particle song optimization. Even they did, I don't understand it. Okay, the purpose of this optimization technique might be talking about something else. But let's assume it's particle song optimization. I feel like they don't even use pick to signal noise. PSNR. I feel like when they writing this article, they don't even use pick to signal to noise ratio to measure how is it. But they did use mean square error. I feel like those papers are full of poop. Okay. They say using medium filter DWT. Now they are choosing RLE, not RLC. Look, they got so many typos. I feel like they're not serious with this article. I feel like they just want like con artists scamming people or something. I just hate it. No. I feel like they don't even know what is those and talking about bulls. I hate those paper. I thought I'm looking at gold, but actually I'm looking at cows. Cow image using IOE, PSO, APSO, GA, compression ratio. Look, it's so high level. I don't even know if I understand how this works. Okay, let's look at PSO. Particle song optimization, adaptive. Look, they got a normal one, they got an adaptive one, and GA. What is GA? Genetic algorithm. Look, I think this is so bad. It's low of cow poop. I'm not kidding. I hope you are not getting bored because usually paper is so under research. I could call it because they don't even know what are they talking about. Well, step 1, input image, noise image. Apply DWT, separate image to pixels. Start on first element of input A. What is it? What is A? I count K0. First element of input data A. What? Oh, start. Okay, this start. This time is red. K0 print input data. K equal 0 print input data. K equal +1. Go to step 3. Apply separate image to pixel. Really, they can claim anything they want without the source code. I can't stop whining because usually when I write this article, they don't even give you the source code. Well, if they did, I don't even want to look it. Must be trash. Must be unreadable. Okay, a proposed system analysis. Okay, the proposed something. SVD DWT combined to perform image compression. If you want to know how to do something, just read the spec of JPEG XL. I hope I can find it. I found it. It uses variable size DCT and it uses XYB color space. And I don't know. Yeah. Now adaptive medium filter. Now it's called median, not median. And they even put a name on it called adaptive media filter. Image segmentation. SVD. Do they even do a spell check on this? DCT technique. SVD then compress, then transform it with DCT, then DWT. Oh, that might work. I will try it later. CR optimization. They come up with bunch of unexplainable pool. Okay, CR is mean compression ratio. Compression. Wait, there's two CR. Now they can decode the image of thin air. Okay, advantage to purpose system. Now they are talking the advantages. Okay, compression of low resolution image with high compression ratio. Also, hypermodal can be useful based on other image types, including real-time video compression. If you want to know, these are full of poop. Sorry, I need to test it, but I can confidently say they are totally scamming you. Like, yeah, you do it with SVD. You transform into two matrix, and then with a sigma, which is 4x4. This 64. Those 64 times 64 matrix. You got two 64 times 64 matrix, and you got this 4 times 4. How can you compress this thing when you got two matrix to deal with it and a sigma that require a float? Wait, why I got this number? Oh, this is horrible. Oh wait, this not SVD. Okay, sorry, I was missing that. Now I have to show you. how it looks like, and it will decompose it. They're horrible. Okay, you got this 64 by 64 image. You can only store them in 8 bit because we know the limit is 255. So after you decompose it, got those ridiculous number like 48. That takes 6 bit. Assume that we need to store this by 6 bit. 64. 64. Now we need 24 kilobyte to store that single matrix. Now let's compare with our grid scale image. It's 2D2. Wow, that's nothing. But if you put it double, oh yeah, the ratio is so bad right now. Like you need to store 50% more of the data, and that's not mentioned. You have those negative number, so let's call them sign bit. Adding a sign bit, it's almost double the data, and you need to store those. Well, it's only 4 by 4, but it's taking 0.4. Let me calculate this. 1, 2, 3, 4. Wait, sorry. Let's move it to 4. So it's taking I don't know. That's too much. How many tools are there? And this float. Then it's 16, 15, 14. Yeah, that's 14 bits. We need 14 bits to store it. Need 14 bits to store those numbers in integer. It's not float. Okay. This SVD is a horrible idea. So I don't know how they say SVD is good for image compression. Like you have to store 2 times amount of data. Oh, it's so cold. The implementation. Now the source code. They actually test it. No, this something matrix. It's 621 by 556 with 144 kilobyte in memory. It's in grayscale by hovering a mouse. Then we went forward to create the compression function, which combines SVD DWT functions. A combination of functions produce the compression input shown in figure 7. With the figure 7. Oh my. No, there's no figure 7. They actually test it, unlike the other article. As observed in the output, only the size of the image change. The resolution of the information are retained. Therefore, is therefore a lossless image compression lossless process. The letter size of the image 268144. Only the size of the image change. Wait. Looks like they were talking now scaling the image. Wow. Wait, I'm so confused. The resolution have changed. The size of the image. It could be about, I think they were talking about file size. The resolution, it didn't change. Okay, this is the source code. I don't know how to read. Okay, compression ratio. How do they calculate? And this existing model. I don't know what is that. But what I need to intro is mean square error. Type complexity. What is it? 5 minutes. Benchmark. It can also be interpreted by the table there are compression called a lower MSE. Conclusion. A hypermodel for performing low contrast satellite. Okay. Low contrast satellite. Lossy and lossless algorithm. Base model reduce the dimension of pixel. They actually use SVD, and I don't get why it's those. Like they were saying something, but it's not clear. They love to use those vague words to talk about it. I don't know what have been said. What is the previous model? Do I miss it? I don't know. They can They can say whatever they want. What is the previous model? Let me check. Wow. What about existing model? Okay. Existing model. So what it was? No, they don't even explain it. They assume that we know. It's horrible. Mean square error, type complexity, they don't have any proof. Set some line of what is this? MATLAB. Anyway, I think that's it. I've done reading this article. It was so hard because they are under research and most of them are misleading or lies. Goodbye. I wish you would stop giving me obvious or confusing flowcharts, like every article but scheme on putting genetic algorithm in abstract or anything, and get rid of the typos, and start dragging out the introduction or later work section. We already got that in the abstract, and actually put the source out no matter how terrible they are, so I know you didn't make it up. I don't want to see pseudocode because they are hard to reproduce and terribly written. Just put real Python source code or something, and please be consistent with your naming. You talk about existing system, and then somehow change the name to existing model. This is insanity to be able to read. How do I get so messed up in the head? I don't get it. The more I think about it, the more I think I will be okay. And the more I don't react to it. She have to do that to save my life. There's only one thing left. The DCT is half a century old, and no one can invent something much more terrifying than the DCT except KLT. I had been grinding for 3 months. Every time I thought I gotten the hang of it, I fell harder and harder. That repository after repository, it was dream crushing. Life is about finding reasons to cope with your unfortunate. I don't enjoy the journey of suffering, but getting the result. But after I got a result, I have to suffer harder. So I might as well drag this journey as long as I can. So the quest to beat the DCT has begun. Want to make you poop your pants.